Hello and welcome everyone to the Intel Network Builders webinar program. Thanks for taking the time to join us today with EnterpriseWeb for our presentation titled Extreme Automation at the Network Edge. Before we get started, I want to point out some of the features of the BrightTalk tool that may improve your experience. There's a questions tab below your viewer. I encourage our live audience to please ask questions at any time. Our presenters will hold answering them until the end of the presentation. Below your viewing screen, you will also find an attachments tab with additional documentation and reference materials, including a number of websites and documents mentioned in this presentation. Finally, at the end of the presentation, please take the time to provide feedback using the ratings tab. We value your thoughts and will use the information to improve our future webinars. Check the Intel Network Builders website partner webinar channel to see what is upcoming and access our growing library of recorded content. In addition to the resources you see here from our partners, we also offer a comprehensive NFV and SDN training program through Intel Network Builders University. You can find a link to this program in the Attachments tab, as well as a link to the Intel Network Builders newsletter. Intel Network business partners have been working to accelerate network innovation by optimizing their solutions on Intel technologies. These industry leaders are recognized in our Winners Circle program, and EnterpriseWeb is a gold partner. Learn more about our INB Winners Circle program by clicking on the link in the Attachments tab. Today, we are pleased to welcome Dave Dugal, founder and CEO, and Bill Malik, Chief System Architect from EnterpriseWeb. Welcome, Dave and Bill, and thanks again for joining us today. Now I'll go ahead and hand it over to EnterpriseWeb to get us started. Dave, all yours.
Fantastic. Great. Thank you so much, Sam. We really appreciate Intel hosting this webinar for us today. So greetings, everybody. Wherever you are joining from the world, good morning, good evening, good afternoon. We're really excited to share with you the performance data and the demo from our stage 3 of our Intel 5G RAN testbed. So for those of you who haven't seen the prior stages, we'll give a bit of a summary to catch you up, and then we'll let you know what we've added to this latest round of the testbed with our partners. And then we'll go into the architecture and we'll provide a live demonstration, actually. So without any further ado, I'll just jump in. So again, as Sam mentioned, the testbed is called Extreme Automation at the Edge. We are joined by some fantastic partners, and we call them an all-star team. So it's Intel, Red Hat, Fortinet, Keysight, KX, and Tex Mahindra. So some of those I think are names that you're all very familiar with. So, and maybe some new names that you'll be introduced to today. So this is now an award. I'm pleased to say it's an award-winning multi-vendor Intel 5G RAN testbed. We won 3 consecutive awards just this winter, so we're very pleased about that. So it's a 5G RAN testbed based on a secure edge gateway use case. We're demonstrating dynamic configuration of Intel Ethernet controller EA10 and network functions to optimize processing of secure packets while significantly reducing resource requirements and energy consumption at scale. So that's a mouthful, but it actually sort of summarizes something that's really critical to the viability of edge deployments, right? Is the need to actually maximize performance, lower latency, and manage power consumption so that you can provide as much energy to the customer use case, and that the automation platforms and the network service itself isn't consuming all of the energy or compute resources, or maxing them out, as it were. So this testbed actually exemplifies a whole bunch of sort of hot button issues that are memes in the telecom space. So from AI ML ops, digital twins, programmable networking, enhanced SON, sort of bringing a new type of sort of service-oriented SON to the RAN and beyond, and adaptive 5G security. So I'm not going to read every detail on these slides. There's going to be a replay made available after the talk, and we just want to make sure the slides had additional detail that you can view at your leisure. So collectively, what we're really doing is supporting autonomous networking, right? It's sort of the sum of all of these things between the automation, the AI, the use case itself, the programmable interfaces exposed by the Intel NIC, the Columbiaville Ethernet controller EA10, FlexRAN, right? IPTK, DPTK. So those programmable interfaces sort of enable then intent-based network services over the top that leverage those interfaces to sort of optimize the infrastructure. So just a quick history, as I mentioned, we're on stage 3. So we started not even a year ago, about 9 months ago. This team came together. Actually, Intel invited us. It was really nice. They invited us to say to test out their programmable interfaces, and they had seen us. We had run the first ETSI NFV proof of concept, and we had run the first ETSI zero touch network and service management POC. So we were invited to do this as well to demonstrate, programmable networking, or the intersection of programmable networking and intent-based networking. We pulled together a fantastic team of sort of usual suspects that we've collaborated with many times in the past. As I mentioned, Keysight, KX, Red Hat, Intel, Fortinet, and Tech Mahindra. We did the first demo. The first stage 1 demo was without the SON. And it was at 1 gigabytes per second, and it was just the use case itself, the secure 5G edge gateway. Stage 2, we brought it up to 10 gigabytes per second, so a tenfold increase in traffic. But we demonstrated, though, the traffic went up tenfold. We're able to maintain latency and power consumption almost completely flat, and you'll see that in some of the diagrams we show later. We then won a handful of awards based on that, which I mentioned. And now we're looking forward to MWC. Also, keep a lookout. We've got a white paper coming out shortly from Intel as well. And we'll be hopefully distributing that in the next week or two. So moving on. So in this new, so what's new for stage 3? So everybody actually contributed some more. And then collectively, that meant there was more integration, more automation, more optimization because of all the additions. So with Intel, we went, in addition to the NIC, we're now using incorporated FlexRAN. So FlexRAN is part of that, and that's giving us some level 1 controls. Keysight has raised the traffic to 50 gigabytes per second. It's including a diverse mix of personas representing, video, HTTP, and REST traffic. Interestingly, they added a Zoom meeting simulation into this demo so that you had voice and video, and we can actually measure the QoS for that Zoom meeting. And Keysight's going to emulate attacks as well from sort of unknown exploits that might be that a network could experience in the real world. Fortinet added its FortiWeb product, which we're really happy to extend the sort of business use case itself, the network service use case itself, with application and API security. And plus, previously we had FortiGate, so that was already giving us SD-WAN and user plane security in the prior stage. So adding FortiWeb extends that now to the application and API security. EnterpriseWeb and our partner KX. So EnterpriseWeb is sort of the automation platform, if I were to summarize that, and KX is the analytics capabilities for this, the AI ML. So as the sort of the platform underlying the solution, the additions from Intel, Keysight, and Fortinet expanded the scope for the SON that we effect together. And we are diving, we're going wider to cover all the elements. And we're also going deeper into sort of the, above and below the cluster, right? All the way down to the network infrastructure, both hardware and software, as well as the application layer. And so we're doing a broader evaluation of state. So it might seem counterintuitive, but because of the increased scope of this use case, there's actually more optimizations we can bring to bear, which is actually interesting in and of itself. So rather than things slowing down, you're going to actually notice that there have been fairly material performance improvements by expanding the scope. So just a real quick summary here, the testbed team. So again, most of you are familiar with all of these telecom vendors, but Red Hat is contributing the OpenShift infrastructure management. In the next phase, we're hoping to go multi-edge node and include Red Hat advanced cluster management. Fortinet has contributed, as I mentioned, FortiGate and FortiWeb. Keysight is providing its SciPerf test agents and real-world simulation. KX is a major provider of AI/ML analytics data services to the financial markets, and now they're coming in strong into telco, applying their same capabilities successfully into this use case. Intel is providing a hosting in their labs, this testbed, which we appreciate. And they're also contributing their Ethernet controller EA10, FlexRAN, as well as their programmable interfaces, IPTK, DPTK, P4, etc. EnterpriseWeb, we are providing essentially an intelligent orchestration platform for not just end-to-end orchestration, but also we're playing the roles of the SMO, the NSMF, the NSSMF, the CSMF. So we're really providing almost an SMO plus, right? Or an SMO plus plus plus, right? In the sense that it's an end-to-end automation story across the RAN, the core, and the transport. We also extend that with lifecycle management and iPaaS type capabilities. And Tech Mahindra, our friends at Tech Mahindra, are the official testbed system integration partners. So let me move on. So this is the use case, and there's a lot going on there because there's a lot going on in the use case. It's a 5G RAN network with a secure edge gateway, and you're seeing all the partners and their various at a high level, right? At a high level, you're seeing EnterpriseWeb here, our cloud NFV product, providing sort of that SMO plus. You're seeing SidePerf Test Agent for testing and monitoring, and you're seeing KX providing the analytics. It's picking up the signals and telemetry. So from all the vectors, very flexibly being pointed at all the vectors relative to this use case. We got the FortiGate and the FortiWeb products and the Fortinet SD-WAN. We've got Red Hat, CoreOS and OpenShift supporting the edge site and the core site. And I think I covered everybody, right? And then we're also incorporating for the core and the RAN, we're using the ONF's Aether project. So it's their SD core and SD RAN. We're incorporating some other open source, Prometheus and Grafana that most of you are familiar with. And again, you can see that Intel FlexRAN is sort of also incorporated into this service topology. Bill is going to go into the architecture of this in much greater detail, so I'm going to skip ahead. Again, there'll be a replay of this, so you'll be able to, both Bill and I speak fairly quickly and move pretty quickly. You'll be able to watch this at your leisure and go through it in detail. So our friends at Keysight are actually doing two different tests for us. One is they're raising the simulation to 1,000 concurrent users, a variety of personas, at 50 gigabytes, a variety of traffic at 50 gigabytes per second. And they're also then subsequently going to insert some bad actors that are emulating sort of common exploits. The results are bringing the sort of the punchline to the beginning. Here is now you can see at a glance our progression from stage 1, stage 2 to stage 3. So stage 1 without this on gave us a really good baseline. And as it was, it was actually very energy efficient and essentially we're putting in a lightweight, low latency solution to begin with. So that comes through. When we introduce this on though, we get some nice improvements here. And then when we raise it to, even though we brought up the traffic tenfold, then we increase the traffic another 5-fold to 50 gigabytes per second here in stage 3. And you're going to actually see that we've actually improved latency, right? We've improved latency under attack. We've maintained a consistently high level of security. This new QoS score that we're doing with Keysight is new, so we don't have previous data for that, but maintaining, I think a respectable QoS score. And interestingly, even power consumption is going down. Again, we added more components to this use case, more complexity to the use case, but we're actually demonstrating less latency, less consistent security, and reduced energy consumption. So I think this is some pretty impressive data. Again, we're sharing all this with you. And we can, if time allows, we can get into some details on our methodology for testing, et cetera. Now, I'll just caveat this that we are running in a lab. At this point, there are no physical radios present. We are hoping in a future stage of this test bed that we will actually introduce physical radios. So, again, just to summarize, the impact of the enhanced SON that we're affecting between Enterprise Web and KX with the support of the traffic and attacks that are simulated by Keysight, SciPerf, we're actually showing that the enhanced SON essentially mitigates the impact of the increased traffic and the attacks. That we're actually, again, keeping things flat, consistent, predictable latency and energy consumption. And those are really two important goals for your edge deployments. The enhanced SON is optimizing energy consumption, and we're actually optimizing physical resource consumption as well. So energy, the footprint of the whole solution, and the resource consumption, compute. Here's another view of that, right? So we can see that latency and throughput are going up. Power consumption is going up. You would expect the traffic is going up. Traffic. This line is showing traffic without the attack. Then this is traffic and the attack. Same thing here for the power consumption. You would expect as we increase the throughput that naturally the latency would go up and the power consumption would go up, but instead we see that continuous optimizations maintain low latency and continuous optimizations drive energy efficiency. So this is a pretty powerful slide. Likewise, just on resource consumption, you can see that the solution is consuming almost a negligible amount. It's almost 5%. So we broke it out a little bit so you can see that in detail. But OpenShift is consuming a few percent, and you would expect that. Testing is consuming around 1% or so, and the KX and Enterprise Web as the automation and analytics is about 1%. So collectively, we're consuming about 5%, but the rest is all preserved for the use case itself, and that really is critical to have lean solutions, lean edge optimized solutions at the edge. You need to do more with less at the edge. The edge is fundamentally constrained, right? It is power and resource constrained by definition. So you want to do more with less. All right, so I'm going to hand this off now to Bill, and Bill's just going to go do a little bit deeper dive into the architecture, get a little deeper into the use case itself, and then he's going to go straight to a demo. Bill, I'm going to pass it to you.
All right, thanks, Dave. I appreciate everyone's time here today, and it's great to be talking to you. So as Dave mentioned, I'm going to go into a deeper dive really on the architecture that he showed earlier. What you're looking at is an exploded view of really the edge and core site. So we're looking into the details, and we are elaborated so that we can get into some more of the, the richness and the capabilities offered by the solution here. In particular, you can see the internal components, and you can see the distribution of the enterprise web components along the top, and some of the interfaces listed. So what's important here is, this is the greater service architecture. So this is actually showing not only the use case itself, so the core elements of the secure gateway, which you see along the bottom. So you can see the P4 interface that we're going to be exploiting in the Intel NIC on the bottom left. So in the E810 Ethernet controller, we're going to be applying all of our IPDK and so on there. And then what happens is, of course, that traffic, what we're most concerned with is the efficiency and of the resources consumed to sort of pass it along the bottom line there between the SD-RAN, the SD core, and all of the components you'd expect in there. We're doing a couple of things, though, that are really interesting with the use case itself that I'll get into in a bit. But basically, there's two things that happen. The control plane and some of the other sort of interfaces that aren't usually secured are secured in this kind of in our implementation. So we're actually taking the advantage of the advanced capabilities from Fortinet to be able to do that. So you can see those orange lines that are connecting some of the control plane and so on aren't usually found, the N2 interface, etc. And then on the bottom right, you'll actually see in that blue box a bunch of business apps that are being secured, basically using a web application firewall provided by Fortinet. So what you get is this sort of, we want to optimize the efficiency of the resources and power to complete that, and at the same time, of course, minimize the latency and improve the performance. Now, in order to do that, we actually have the elements that support the platform itself, right? So the delivery of this. So what's sort of pretty important here, and if you look across the top of it, you'll actually see the enterprise web components. So you see a number of boxes there, and they should be familiar to you. They come from a number of different standards bodies. And what they are, that's actually interesting here, it's enterprise web decomposed. We have a small 50 meg footprint, very easy to deploy into discrete instances. And each one of those has the standard interfaces and capabilities implemented for the component you see, an SMO, an NSO, etc. But what this gives us is actually common technology implemented across all these interfaces. What that kind of translates to, it means that we can actually do things like, rather than a traditional SON that's just focused on the SMO, it's a very, a very siloed kind of implementation. We can actually take advantage of sort of end-to-end, if you want, right? We can actually look at a lot of optimization vectors, everything from the services, slices, the functions, network infrastructure, compute resources, and power. We can account for all of that when we're implementing a SON. That means that we can configure all of the components, even the hardware, right? So going down to the actual adjustments we make in the Intel NIC are all driven by that kind of full visibility or observability across all the deployed elements, things like FlexRAN, Prometheus, Grafana, IPMI that you see in the top right, really sources of information. And then, of course, we can even tie in information from CyPerf for the performance when we're doing the testing and so on, so that we can train KX that you see in the top right, which I think we've mentioned is the AI ML partner in this solution. So what they give is actually a pretty exciting component on its own, a real-time database that's really up to the job of taking all of this information, all these many optimization vectors, and as soon as we basically point it at anything, we're immediately able to observe that environment, and then that feedback flows back to enterprise web. We can then use it for mitigation plans to return the quality of service and all of that, which I'll talk about a little bit more in a minute. But that's a really powerful feature of this implementation, that kind of SON that we are able to realize using KX and enterprise web, and expanding it beyond what you find in a normal SMO. We'll see that is pretty dramatic in the actual demonstration. And then just to complete the description here, of course, CyPerf, without them, we have no testing and no simulation here, right? They're the real proof point of being able to show that, well, FortiGate and FortiWeb have a huge advantage in block rate in this kind of a case. So they're providing all the traffic, and we've talked about it already. I think Dave's mentioned the digital twins that are doing the exploits and so on. So we'll go into some more detail as we go. But that's a good overview of the solution architecture. Now, I'm going to take a minute to just drive into a couple of the actual use case specifics. So you see the FortiGate and FortiWeb components on the right. We're going to zoom in on them a little bit. Let me just switch the slide. Okay, so as far as the actual securing of the control and user planes, we have the FortiGate firewall here, which is an advanced and popular product. Really, it's an industrial strength next generation firewall. It's got a lot of rich capabilities and a great interface, but the way most people deploy this is statically. Especially it comes back to the automation tools that they have in place, but typically you're going to put your firewall in and manually configure what it's pointing at and protecting. In the case of something like the testbed here, though, we really want to be able to take advantage of the fact that we can dynamically configure it. You have a changing app behavior in a volatile environment. For instance, CyPerf here is going to simulate 50 gigabits of traffic. That's going to actually trigger adaptive security response from enterprise web, KX's SON. Basically, it's going to identify, hey, something has to change to cope with this larger amount of traffic. It's not as simple as just scaling one element or anything like that. It could end up in scaling the control plane even. It depends on what the actual traffic is going to require. But what happens is that as the service is actually changing, as new participating applications come on, what we're going to be doing is in lockstep, we're going to reconfigure FortiGate as required. So we're going to be actually modifying that configuration dynamically as things change. Now, the nice thing is if you kind of follow this to the newer ad that we had for stage 3, we didn't just use the Fortinet's FortiGate anymore. It's great on its own, but what we wanted to do was extend security even more. We're using this SON over the top, which has all its nice features and is great, but we can also take advantage of AI at the level of actually adaptive application security, which is exactly what FortiWeb in this kind of case is giving. It has its own internal AI models that are able to actually look and uniquely learn from experience too. So what they can do is actually look at the exploits that are heading towards these applications, even if they're new applications. We really just, in terms of the dynamic side for Enterprise Web, we just point out FortiWeb at it. It does really all the work for us in terms of securing things like REST interfaces, even the actual application itself, its interfaces. So you get sort of this double protection. You can see you got FortiGate already securing basically the physical connection, the CGNAT, et cetera, that are on that N6 interface. And then we have this extra layer of security that we apply around the apps. So it becomes a really advanced feature set. And I think Dave showed earlier, we've got upwards of 98% block rate. And it shows here because when Cyperf comes in to emulate the bad actors, they're actually sending all kinds of different exploits specific to the apps. And FortiWeb in this case is actually able to adapt and secure them just as well as it did the initially deployed apps. So a couple of nice features about the use case itself. Now, just to set up the demo that you're going to see me go through in a minute, obviously, as much as zero touch makes things fast and efficient, we can't cover everything in the 15 or 20 minutes. So I did some things in advance of the demo, but again, they're all done with the same automation tooling, if you want, right? That same platform in place can carry out all the tasks you see here. So OpenShift with Prometheus Grafana have already been deployed onto the Intel hardware. We're running RHEL at the edge and core. The Cloud NFV solutions, that's Enterprise Web, has actually been deployed itself via an OpenShift operator. And it'll be important to note, I'll talk about it in a minute, but we're using operators all over the place here, right? Red Hat gives us a really good advantage there of being able to use a common interface for the LCM management. Usually it can be a bit of a problem for a vendor to implement because they can become one-off. It can be if they don't already have one, it can be a bit of a challenge to build. And it's a sophisticated programming effort. But what we're able to do with Enterprise Web is actually generate those operators for all of the participating elements. So we can make it really easy for one of these a partner to use or take advantage of what's there in OpenShift as far as operators go. You will see a little bit of that in the demo, but it's there across the board. Then, of course, the controllers for Cyperf and KX Analytics are already deployed. So they're already running right now so that we can easily tap into them. For Cyperf, we do need to deploy an actual agent onto the, two agents really, to be able to simulate the traffic and then observe it. So we do that as part of it, but the controller's already there. And then the last part here that's pretty important, I'll show a very little bit of it, is that the day zero has already been done for this, meaning we've already onboarded all the solution elements, all the partners, everything else have been modeled, their standard interfaces generated, and then registered in a catalog. Is where I'll really start the demo. I'll show you a couple of those objects, give you a little bit of info, but that's an important part of this demo. Then we're going to focus on the day one and day two. Once you have those in your catalog, how do you easily compose? You can see it down here at the bottom when we talk about design time modeling. How do I declaratively compose this service to give us the gateway, firewall, everything else that we need in an intent-based way? So we'll model the service graph. You'll see me add a few policies to it. We'll build the service chain. It'll be pretty quick, but it's the kind of building blocks that we are able to leverage very easily in Enterprise Web to make this quick and powerful. The platform is then going to generate a deployment workflow. Whatever it is I decided that I wanted connected, in this case, the firewalls and what have you, the system will build the appropriate deployment workflow for me and install OpenShift operators to work with each of the elements. We'll publish it to a catalog, and then you're going to see me do day one, which is really just the deployment, handles all the implementation details. And then day two for us really means the sort of ongoing operations, right? So in concrete terms, it means that SON that we talked about earlier is going to recognize changes, problems, what have you, within the network based on its models. And it's going to signal to Enterprise Web to perform mediations. So you'll see that, or mitigation, sorry. You'll see that in place in my demo. As far as what that single deployment workflow looks like, you're kind of seeing it here on a slide. You'll see a exact, well, a concrete implementation of it, or it'll displayed in the UI in the system when we get to that. The labels will be slightly different and so on. But basically what you find is that canonically, this is kind of the deployment workflow that Enterprise Web has on any service. Establishing an infrastructure services, instantiating the services on top, and then configuring them. The thing is, though, of course, all the values underneath are going to be wildly different based on where you're deploying, what you're deploying, and so on. But again, that sort of common model that all our objects, all the participating elements are drawing from, make this easy. So on the left, you can see things like installing the actual OpenShift operators and everything else to provision the network, including the L1 infrastructure. So actually tying into the APIs and sort of command line interfaces provided by FlexRAM. That'll be part of this. Then our instantiating our service is really just, you can see operator, operator, operator over and over. We've sort of normalized that. Enterprise Web will take whatever interface is there to establish all the elements, right? Even the non-functional ones, like putting the actual cyperf agent. And then finally, it's a set of configuration. And you can see there's a number of different places the configuration happens in ways, whether it's SSH, REST, even to the point of a P4 interface against that E810 controller. All of those are going to be handled again. It's a single workflow process. If anything fails, it'll roll back. It has compensations, all those kinds of things built in. In the demo, it's just going to be a really simple, nice deployment, but it's a very robust thing with a very deep ability to trace into it and look at all the details as needed. So that'll be the workflow it will do. And just a couple of seconds on the SON itself, right? We already introduced quite a bit about it, but it's working at multiple levels, right? So what we actually have, you can look at it in the lens of anything, like what are my RAN optimizations looking like? This is sort of what it is, right? We've configured the real-time RIC that's in the Aether to push handoff decisions and other information into KX. It becomes a vector into KX. Of course, there's other vectors. You can see SidePerf on the bottom actually pushing some performance telemetry, Prometheus and Grafana, and the other tools that are there for kind of resource monitoring, again, are all coming into KX. But it's connected to KX isn't just supplying, getting these singular inputs, right? It's an end-to-end process. It's
Bill? Bill? Okay, so let me just pick up where Bill just dropped off. So I think he's going to try and rejoin here. So he was doing a really good job too. So let me just keep on pushing this through while he rejoins. So he's just told me Google Chrome crashed. So day 2 operations, closed loop RAN optimization. So again, this deck has actually been provided as part of the attachments.
My apologies, guys.
Okay, fantastic, Bill. I was just pointing out that the deck was the deck, and there's a link to the last video as well for stage 2 is in the attachment section here. So if you look, there's a paperclip on the right side, and you can get to this PDF, as well as there's going to be a replay link sent around by Intel. Go ahead, please pick up where you are. Bill, yeah. Please be mindful of time. It's 11:33.
Yep, I'll get right back to it. So just the point to reach here, though, is that there's a lot of vectors going in. This isn't where our SON ends. I guess that's the best way to say it. In regards to, it's real time. That's going to be a lot different than the normal SONs that people are used to seeing. But what it does is it extends out to even include things like, in this case, it's very important for us to do closed loop around the 5G core. So we're starting to exploit things at the actual networking level. So it can make, it's quite concrete here on the left, right? When we're getting these signals back regarding how the core is functioning and the actual SDN level kind of information, well, we can use that to actually reprogram the NIC. So that's a lot of what's driving after the initial kind of P4 optimization, optimized programming. This is what's doing the ongoing. If I apply an AQ, for instance, I can offset some of the traffic that's going to be required to, prioritize the firewall over some other component if it's under attack, those kinds of things. So that's an overview of the solution. So now I'm going to get right into the actual demonstration itself. And I'm going to take you through a lot of the concepts that you've seen here. So just a second. Okay, you should be seeing my screen. And we have an environment now. So quite literally, we're going to start with just, this is what's been deployed. So it's an OpenShift instance. Their container platform, one project, and really the only thing deployed in it is our cloud NFV solution via an operator. So an enterprise web solution here, and you'll see there's no workloads, there's no pods, there's no deployments yet. We'll come back here when we actually deploy the service. We're going to look at one of those enterprise web modules right now. So I mentioned earlier that day zero, we're not going to really concentrate on it, but I'm going to show a little bit. Well, we're logging into one of the components that's actually used for doing that day zero onboarding, right? You can see a catalog here of all the components in Enterprise Web, or the solution elements that we talked about earlier. Every one of these represents an object with common metadata in Enterprise Web. That allows you to have some common data collection, and it allows you to do things like search and compose them and even match them based on that sort of, we'll just call it a common ground, or really what's an upper ontology. We map all the details from them so they can be consistent across, and we can treat them like they're the same kind of thing. Of course, based on types and subtypes, data collection might be different. So I'll give you a couple of examples. In this catalog, we've got the FlexRAN component that's really a utility. It's a set of libraries that's interacted with a lot differently than a normal CNF. If we want to look at the firewalls, for instance, we can see, okay, a number from different companies, including firewalls from Fortinet, are all going to be modeled in here in a common way. And this extends to everybody, KX. We're going to look at the Aether component, which is really the Aether stack for the RAN and the core. If we drill into it for a second, a couple of things. It's an object. So for every object in Enterprise Web, since they're all the same, we extend a case over them, right? So it gives you consistent IT governance policies across all of them, things like versioning, access control, security. It's all right down to a granular level. It's all nice and easy. Once we go a little bit beyond that, we can manage the actual inventory. We can see any instances deployed. Of course, we don't have any yet. And then we're really getting to the package, which is very quickly, all CNFs kind of have a common kind of feel to them. We define something like, we point at it and say, okay, this is a 5G stack. As soon as you start to make a few selections, the system is mapping this to an upper ontology. What it really means is the system can understand that the 5G stack is there, and it can do things like actually autofill most of the properties that are needed and generate the interfaces that are behind this. So when somebody actually onboards this, of course, things like a descriptor become available, PCRFs and so on, the internal components. Some of them you saw in that slide a minute ago with the architecture. There's a lifecycle management that gets generated, and then there's that standards-based set of interfaces. So I don't need to go in and write a whole bunch of interfaces for Etsy or anything else like that. They can just be generated for me for the component that I'm working with. So what that provides me with, though, and just to be clear, each one of these takes between 15 minutes and maybe 2 hours at max if it's a really complicated component. But then what that gives you is a reusable component where most of the work is really done for the, how would I say it, the service designer. So I'm going to play the role of that service designer. So I'm just going to log out of here. I'm going to go in as a service designer. So this is someone, again, using Enterprise Web, slightly different user, but they're going to be someone who wants to compose a network service. So again, it's in my catalog. This is one that we already created for the demo service for phase 3. This is the secure gateway with firewalls and so on internal. Same thing, IT governance applies. I have a little bit of a different view, instances, VDUs, etc. But again, just based on the type, it's all going to be very similar. We have this kind of, we're looking at what is really a descriptor. And as far as the actual service goes, this is all that someone had to do in Enterprise Web to be able to take advantage of what was already there, the good components that are provided by all the partners, is basically pick them out of the catalog. You can see the ones that I clicked into before. All of this is going to be provided. I have a service graph down here that I combined. And at any point here, I can now go in and add configuration over the top. I can do something at the service level, service chaining policy, for instance. I can look at the actual components and both their configurations and any of the intents. Right? So we keep talking about an intent-based service, right? So what does that actually mean? If I look at any one of these, so I can set things at the actual individual component level, or now we're talking about a service, so things that will apply generally. So I'll drill into a couple of these, right? And actually, let's start with the Aether stack, right? So what I can do is expand it, and at any point here, this is kind of one of the keys of Enterprise Web. We give you out of the box a minimum viable solution. In most cases, it just deploys and works and it's fine. If as a developer you want to go deeper, as an engineer you want to actually play with the lower level configs, you can start drilling in. You can even use an API first method to go further. It's all going to be under control and all that kind of stuff, under governance, but you can do it if you need to. But for now, what we're going to do is go with what's generated. So when I onboarded this Aether stack, I set up the properties that you saw before. Now when I apply it into this service graph, it's aware, of course, of the context, right? I can see that, well, it knows that I have for the FortiGate products involved. I can actually just flick a switch and say that I want to secure the control plane. It'll identify them, and I get the chance to edit them as I go. There's some placement parameters, the normal thing you expect, affinities and anti-affinities. So these are sort of some configurations, and if any of the components have advanced configs that you expose, again, they're going to be listed here, driven by data, whatever you want to do with them, you can you sort of add that. Then what you get into is the more exciting part, which is all of this kind of intent based, right? So what is the actual intent here when I have this component in? And these will all roll up, they all get fed into the SON basically. But what I have is basically a couple of goals here. I want to maximize effective throughput. Again, it's based on the application model I attach to this. It understands there's concepts like throughput and what have you and what they are. So that means minimizing latency, et cetera. And you can see in this kind of case, it's even to actually minimize the switch speed on the ADQs, right? So adding and removing them and to see how that gives you value. There's some constraints you can add to this, and honestly, other kinds of policies. And this will apply to any one of the elements in the service at large, right? So if I pop into a firewall, for instance, I'm going to see same kind of things, optimization parameters. I'm looking to maximize my block rate. Some of the minimizations are the same, like the power consumption, and then obviously there's no other ones added on this case. I just go through each of them. I set those up. I set up my service chain and anything else I might want. Even you can see slicing comes in here. We have a little OpenSIP web service. It's just what I'm going to use for the demonstration, so you can see the effect of traffic and so on the service. But that's all. It's in my catalog here. It's nice and easy. It's all connected down at the bottom, and then based on that, I think we talked about earlier in the slides, a single deployment workflow. So what the system did was it analyzed my deployment, and of course I'm pointing this at a specific environment, right? So I'm pointing at this OpenShift environment. So it knows to do things like, in this case, bind to my existing service. It can generate the CRDs and everything else that are going to be needed. It deploys the OpenShift operators. I won't go through all of the detail here, but it even includes some things like actually doing the testing as a verification stage. What the system does, though, is it gives me for free that sort of basic service that does everything that's needed for configuration. It recognizes two kinds of firewalls and what they are. And when you're in an edit mode, you can drill into these to whatever level of detail you want and configure what that task is going to actually look like. But this gives me a kind of minimal viable solution. It'll do the deployment through standards-based interfaces. I can execute an API, for instance, to create a new deployment. And what it does is it actually gives me an easy way of modeling. And as a developer, if I want to come in and add new customizations, whatever is needed, I can come in and do them right here.
So, hey, Bill, I just add that if you go back to that view, that's a state chart. So if people are not familiar, as opposed to showing just a static workflow, and many people who have worked in business processes before know that workflows can explode to being the size of a wall and be almost incomprehensible. Here, this is a state chart. The columns represent stages of the process, and this happens to align very closely to the slide that Bill had shared that showed the deployment workflow in a PowerPoint. And this is actually what the system generated. There's certain stages that this deployment needs to go through. Each stage has a set of tasks. The system can execute as many as possible in parallel, and then as necessary, it processes some in a serial basis. And then as it completes stage by stage, it can advance. The whole thing is transactional, so that if any stage is to fail, the system, it will actually attempt retries and any other policies that are applied, circuit breaking, all those kind of things. But if any stage fails, then the whole deployment has to fail and be rolled back or compensated, and with all the resources being released, right? You can't have a partially deployed service. You want the service to deploy deterministically. It's it either succeeds or it fails. So go ahead, Bill. I'm sorry.
No problem at all. Yeah, and that's all a very important detail. Now you're going to see the system actually carry out that process. So we've got a little listing here with instances. What I'm going to do is I'm going to pop into an API client. It just lets me turn on and off the different elements of this service. So I'm going to go ahead and execute that. And what you're going to see is that it's deploying here in the background. You can see already the system's recognized this new deployment. And if I pop into OpenShift here, what I'll actually see is you can see that it's starting to create these pods and deployments. And usually it lags a little bit. You're going to see this catch up. Okay, so we're active already, right? So we've got this service that spun up. It installed all the operators, did everything else you needed in OpenShift. and I could start to enjoy this service. There's a couple of things that are worth noting here. Is that we talked about how there's a life cycle across this, right? What did that, and it's kind of a walk down, right? We described the intent that we wanted, what the service was. You saw the generated life cycle management operation, right? The deployment at those high level stages and what they were configured to do. And now the last piece of that puzzle is really how it translated that into real life commands. Right, so you can actually see at a much lower level, okay, there was a secret required by OpenShift, whatever. It handled that dependency, and then it starts to go on, calculate my service graph, resolve environments, create namespaces, configure FlexRAN, create subnets, and you can go to whatever depth you want. Create a VDU for the NSMF, install KX. Eventually, you'll see some configuration commands, Fortinet firewall, what have you, the interface, configuring our NIC, even to the lower level of what kinds of operations are actually needed in that space. So 90 operations or something, the system calculates in milliseconds. And then it takes maybe a few seconds to actually deploy, and then we have a service we can start to enjoy. Now you can see all the VDUs here. There's that web conferencing element, all the Aether components, and if you keep going down this, you'll see Keysight comes in, KX, Fortinet firewall, what have you. You can go into any of the interfaces, and all that's configured for you and set up. Now the only thing we didn't do here, right, to be clear, is I didn't turn on the SON policies. If I do, the problem becomes it's going to be too quick for me to actually demonstrate any kind of problem, right? The whole point of the SON is to mitigate issues that are occurring. So I'm going to set this thing up a little bit. I'm going to actually make a call across the service, right? So I've just got a little SIP phone, and I've done some redirection on the addresses. It doesn't matter. You can see here, okay, I'm getting a call, right? I'm going to use this over the channel, so let me just mute these so it doesn't get annoying. And the whole point of this is to be able to show you one of these quality of service kind of things, right? So we've got our video. You saw me at the beginning. Hi, I've got two connections, right? I've got one that's on my cell phone here, and then one on my computer up here, right? Great. What's going to happen though is that as soon as we start simulating traffic, one of these is going to go away, right? And I'll show you that right here. So we'll do two things, right? We'll go, there's a KX dashboard. So we're going to actually be able to come back to this in a second. So, oops, sorry, let me get into this. All right, so we'll go into the KX dashboard in a moment. I've got my web client. I'm just going to start the traffic. So this is going to turn on that 50 gigabits, et cetera, simulation here. And what will happen is that it'll be pretty dramatic, right? Once the service starts, pretty quickly, things have grown to a level where we can no longer actually work with them, right? So you can see here, we've actually got, how I say, it's beyond the quality where we can even see a video, right? If I pop into that KX dashboard, right? So this was what was actually monitoring the SON. You can see that up until that point, everything is sort of a flat line, right? Everything is behaving well, and I won't go into the details of what these are, but a couple of signals that are pretty important. One is really related to the RAN, one's related to the core. It's great, but now it's sending signals up. It's actually recognizing that there's a problem, and it's sending the cues and signals to EnterpriseWeb, but right now we're ignoring them, right? So that's why you can see that there was a problem, my Lin phone, et cetera. Yeah, it's not actually working right now. What we'll do though, that's going to be pretty pretty cool here, is we're going to activate a couple of policies really quickly, right? So let's get them actually activated here. So this is turning on for the even after the first one. You see the service is back here on the right. So let's just get rid of that for a minute. If we watch this graph here in the background, we'll see that it's coming back to a flat line, right? It's actually coming back to the kind of quality that we want. And this is a real-time representation of what Dave showed you in that slide, right? It's not a one-to-one. This isn't the exact latency and power, but what we're seeing is all those signals are back down to a level where mitigations have already taken place. If we go into Enterprise Web, here's the exciting thing. If you remember that life cycle that we saw a minute ago, the API hook was the only thing we had, right? We had the instantiation, basically story, that told you everything that was going on with it. But now what we have is a bunch of these KX triggered changes, right? We can actually see we're adjusting spectrums, we're changing P4 policies. There'll even be some scaling that'll happen in here. And what quite literally happens is that signal hits EnterpriseWeb. It basically is telling it to do something in terms of a mitigation, actually work out a simple workflow. So in this kind of a case, okay, we look up, we might need to adjust P4. That's basically what the signal's telling us. We look up the IPDK based optimizations. We query KX for some more information, apply a template for an ADQ. Eventually, we actually get a reconfiguration of the NIC, and it returns our service to the kind of quality that's expected. So I know it's a little bit quick, but hopefully that demonstration kind of drove home the kind of power of what we're able to achieve here in the test bed. So I'll be happy now to turn it back to Dave. Thank you.
Great. Hey, thank you, Bill. That was fantastic, actually. So good run through. We just completed this stage 3. So you moved through that quite well. So hopefully that was compelling, clear and compelling to everybody. What you can really see there is the power of this multi-vendor integrated solution, right? This has been a great collaboration. I mean, it's a really strong consortium, not only with great companies, but also a hat tip to all of our the team members from all the companies, because it's really been not only good work but enjoyable collaborating with everybody. I just want to call out that we will be at MWC working across all of our partner booths, and you could see the partner booths, their halls and stand at MWC in Barcelona at Feb 27 to March 2nd, 2023. We also provided a contact. So if you wanted to schedule something in advance of going to MWC, feel free to reach out to any of these contacts. They're all knowledgeable about the testbed and their company's involvement in it, as well as the overall testbed story. James, let me know if you have any questions. I'm sorry, Sam. Why did I call you James? Sam.
No worries. I get that a lot, but I don't. But I didn't want to embarrass you. But thanks so much, Dave and Bill, for that great presentation. We have had several questions come in from the audience while you're presenting, so let's get those started. The first one is, thank you so much for sharing the demo performance data. What was the testing methodology that you used?
All right, so that is a great question. We take that seriously because we're doing good work, so we're proud of it. And we want to share the results. So, and we're very keen to make sure that it's objective, verifiable, repeatable, et cetera. So, Bill, I don't know if you want to add any color on that, because I know you work closely, particularly with Keysight, and if maybe you could share a little bit more detail on methodology.
Yeah, so we had to isolate a lot of things to be able to share in this test bed. So there's a lot of A/B testing that goes on with these kinds of products, and of course, with the kinds of scales that we're working with. The thing that's nice about Keysight is you can quite literally push a programmable test plan, right? So you can turn on and off the things like the actors, the exploits that were there, so you can measure with and without, the attacks going on. The number of users can be scaled and whatever, and so it becomes something very easy for you to be able to, script out these tests, or run them over and over for the analysis purposes, and then basically just collect and aggregate the data yourself. So there's a lot of A/B testing with turning on and off the firewalls, for instance, the various components. And then there's also a lot of isolation that we tried to do across the individual components. So isolate what their contributions would be to the total power. And the power savings comes out of things like turning on and off the SON. And so we can coordinate the testing, and basically we can set up a bunch of test cases that we can run with and without specific optimizations to effectively isolate the power of a specific, say, optimization vector, for instance. So a lot of that kind of testing has been done, and that's really the basis of most of the analysis.
Great. And we're also creating an analysis document that I don't know if we'll make it public so much, but we'll share it with interested parties. So if there are communication service providers that are interested in the test bed, would like to do a trial, or learn more, we will be providing, I don't know, say a 5-10 page document, Bill, that goes into all that.
Yeah, 10 or 12. It's a little bit big.
Good. Okay, great.
Fabulous. Thanks so much. Second question is, what effort is required to deploy the use case, and what other tools and engines are involved?
Okay, good question. So I'll answer that in a couple parts, taking that step by step. So as far as effort, the actual initial deployment was done in 2 days, everything, right? So literally all the partners on that side, you can see all of their products were essentially modeled in EnterpriseWeb. And Bill went through that whole idea of everything regardless of what it is. So Keysight, we have an object that represents Keysight metadata that allows us not only to deploy it, but it also allows us to lifecycle management and configure it as well. But same thing for Fortinet, FortiGate, FortiWeb, KX itself, right? That facilitates the training of KX, and so that semantically EnterpriseWeb and KX are speaking the same language, as it were. Once we onboarded them, Bill did that in about a day, did the composition effectively the next day. And, that was just initial. So the initial effort was honestly like 2 days. Now, then refinements go on and we play with the traffic and all those other details that Bill was talking about. But as far as the day zero, right, getting this all together, that was done in 2 days. So let's say Bill's super good at it, so maybe 3 days or for somebody else, but still that's pretty darn good. And as to the tools, literally there are no other third-party tools than we expressed here on the left side there that of the partners, because Enterprise Web is a comprehensive automation platform. You need no other gateways. You need no other brokers. You need no other integration tools. You need no other orchestrators. You need no other workflow tools, business process, nothing. The UIs, everything are fully constructed out of Enterprise Web in 50 megabytes. In 50 megabytes, we're replacing the entire, what would traditionally be deployed as a big fat stack that would be siloed, brittle, would have all sorts of issues with scalability, security, et cetera. Enterprise Web is a cloud native, edge optimized platform in 50 megabytes. And then it could be deployed in a variety of roles like we described. So we could actually literally take Enterprise Web, because it's only 50 megabytes, we could deploy it as the SMO++, right? Where it's exposing the SMO standard interfaces over SMO standard non-real-time RIC capabilities, and do the same for the SMF, et cetera. So it's really benefiting from sort of, I would actually describe it as a common middleware technology that really streamlines the solution architecture, right? Because I think where telecoms are struggling is they can do anything one-off, right? Anybody can do anything one-off in software, right? That's not a problem, right? Anybody can take a handful of components and manually integrate them together and deliver a solution. But the problem is, does it scale? Is it secure collectively? Does it perform? Is it, is it agile? Is it easy to change, to modify or extend? And that is not the history of IT, and it's not the history of telecom either. They build vertically integrated stacks that are expensive to deploy, time-consuming, expensive to deploy, hard to change and modify over time. So we're addressing that by creating a common technology, really represented in this case by Enterprise Web and KX, being sort of that automation and analytics layer. So good question, though. Thank you.
Fabulous. And then one more to close this out. Could you please clarify on how intent is being modeled and implemented?
So Bill did, it does deserve more time to give it justice, and the problem is we tried to cover as much as we could in the time allowed. Essentially, because Enterprise Web starts with the notion of a harmonized telecom model, right? Our deployment, that 50 megabytes, includes this graph-connected model that has the O-RAN concepts, 3GPP concepts, IETF concepts, TMF open APIs, ETSI concepts, you name it, Tosca concepts, where it actually has a graph-connected model of the end-to-end telecom domain. So we can be that end-to-end across the RAN, core, and transport for pretty much any use case. And so that's the starting point for Enterprise Web. That model essentially creates common metadata and relationships. That is the foundation for describing intent. In other words, if a service designer or an engineer wants to declare their intent, that is essentially a high-level abstracted notion, right? In other words, they're saying, I want this to be energy efficient and low latency. And that's a very high-level statement. They're not actually, it's declarative in the notion that they're not telling the system how to implement that. They're just telling the system what they want implemented. And what that means is you need a really good abstraction that can understand what the engineers or designers are asking for. And then the runtime, in this case, Enterprise Web, is implementing their intent and managing that. So that's what creates then essentially a zero-touch operations, because the designer told us what to do. So as long as the service is performing within those thresholds, it's going to be maintained by the platform. If it goes out of threshold, the system is auto going to correct it to try and bring it back into thresholds. And all along, that can be monitored, through the either API or UIs, so through dashboards and portals, so that it can be observed as well. Bill gave you those great views into the traces, where the system's literally telling you every single thing it's doing. So I guess the other side of that is, as a no-code platform, one of our missions is to make things is to streamline onboarding and accelerate service delivery, et cetera. The other part of our mission is to, while doing that, while making things easier, while removing developer toil, they call it, right? Tedious work that's repetitive and difficult. While doing that, we also still have a responsibility to make sure everything is transparent to the engineer, because we've never met a telecom engineer that lets us off the hook. They're never going to accept magic as being the answer. They're going to say, how'd you do that? What did it do? What was the policies it followed? When did it do? Who set that policy, right? What version, right? All of that is 100% transparent based on, of course, your security permissions.
Great. Well, if there's nothing else, thank you, Dave and Bill, and to our audience for joining us today. Please don't forget to give our team a rating for the live recording so that we can continuously improve the quality of our webinars. We look forward to you joining us again next time, and don't forget to check out the various resources available in the Attachments tab and on the Intel Network Builders website. Thanks again, David, Bill, and this concludes our webcast.
Great. Thank you so much. We'll be sure to give you a good review, Sam.
Thank you. Yeah, appreciate it. Likewise. Have a great day.
Take care.
Bye-bye. Ciao.